Okay, so first thing we're going to talk about in this unit is climate. Okay, and what climate is the long term, that's the key, long term, okay, prevailing weather at a location. All right, so historically, if we're looking at the climate here in Okotoks, okay, we could say, what kind of things would we describe if we were describing the climate in Okotoks? Okay, precipitation is certainly part of it. Okay, Okotoks is a relatively dry place. I mean, if you're looking worldwide and comparing, Okotoks is relatively dry. There are a lot of places a lot wetter than here. Okay, sometimes we don't get a lot of snow. That has to do with two things: precipitation as well as temperature. Yeah. Okay, precipitation and temperature are two major components of climate. Okay, because I mean, think about it. When we look at the weather, we kind of want to know a couple of things, maybe three things, okay? We really want to know what the temperature is outside. That's the first thing we want to know. How heavy a coat do I need to wear? Do I need a coat today? Today you needed a coat. It's cold outside, okay? Is it going to rain, snow, hail? What is it going to do? Precipitation. You want to know that, okay? Again, that determines what kind of clothes we wear, whether we bring an umbrella, okay? And what's the third thing we might want to know? Yeah, we want to know wind. Okay, I mean, we get a fair amount of it here. We've had how many days this year since school started where we had a wind warning? Okay, we've probably had 10 or 11 of them. Okay, where we've had winds in excess of 100 kilometers an hour. Okay, we kind of want to know that. Okay, it affects how we dress. It affects how we walk. How difficult it is to walk in a straight line. Okay, whether your house will still have shingles on it when you get home. Okay, things like that. Okay, we want to know those things. That's part of weather. Okay, and one other thing, if you open up your weather app on your phone, in case I don't know, I don't look at the Apple one ever, but like the Weather Network, for example, always tells me one other thing in addition to precipitation, temperature, and wind. Okay, usually tells me humidity, but I'm going to relate that more to like precipitation and temperature. Right. Is it going to be foggy, sunny, and how much light am I going to get? How many hours of it? Okay, they usually have sunrise and sunset on there as well. Of course, right now, okay, we're approaching the shortest day of the year because it's December 17th. Okay, we come to school and it's dark, and we go home and it's dark. Okay, we get our 6 hours of daylight, and we have to be happy with that, right? So, advisory: at lunch, go outside and just look at the sun for a few minutes. Okay, it'll do wonders for your mood. Yeah. If you stay inside all the time and never see the sun, your vitamin D will drop, and it's all bad. No, December 21st is the winter solstice, right? So that'll be the shortest day of the year, right? So there's good news. After the 21st, the days are getting longer again by about 3 minutes a day. Yeah. I'll take it too. I hate short days. Okay. All right. So those are the components of climate: temperature, precipitation, light, and wind. And long-term in Okotoks, those are pretty consistent. I mean, certainly there's changes that are going on in the averages, okay? But for the most part, over the last 200 years or so, they've been pretty consistent. Okay, Okotoks is relatively dry, relatively windy. And where does our wind come from typically? Okay, well, we get Chinooks, and they always come from the west, but typically our prevailing winds come from, southwest. Okay, typically the prevailing winds are that they come from that direction, this direction. Okay, typically. Right. Once in a while, we're going to get winds that are not from that direction. When we do, we're usually in for a change in weather. Okay, if the winds are coming from the southwest, we can expect that weather is going to be pretty stable. Okay, but as soon as the wind changes, especially if it's coming from the northeast, we're in trouble. Okay, nothing good weather-wise comes from that direction. Okay, so those are the components of climate. Then there are factors that affect climate. Okay, these are the things that essentially make the components the way they are. Okay, factors would be things that make an area dry, or make an area wet, okay, or make an area hot or cold, or an area windy as opposed to not windy. Okay, things like that. Right. So these are the things that will essentially affect your climates, okay, and make your climate the way it is. It's really important that we understand the difference between the components of climate, temperature, precipitation, light, and wind, okay, and the factors that make those things the way they are. All right, we're going to look at the effect of climate on plants, animals, and humans just a little bit there. We've kind of talked about that actually already when in the plant unit, when we were talking about the abiotic factors, you know, and why they made the trees grow the way they did and stuff. That's kind of, we already kind of talked about that a little bit. Describe energy inputs and outputs of various environments. What's the only energy input from all environments, essentially, except for deep ocean ones? The sun. That's easy. Okay. All right, and create and understand climatograms. So we're going to look at what a climatogram is. Okay, it's basically a graph that shows us the prevailing weather at a certain place. Tells us temperature and precipitation month by month. All right, so climate, the prevailing weather conditions at a location. Prevailing weather. Okay, this is where Leo Chinook DiCaprio doesn't understand things. Okay. We understand that the prevailing weather here is that we get Chinooks. They happen. Okay? If you don't like the weather in Alberta, wait 5 minutes. It'll change. That's how things go here. We understand that, but I mean, if you're not from here, maybe it's scary. I don't know. Okay? So the major components of climate are temperature, precipitation, light, and winds. Okay? We got to know those 4 things. Okay, in this picture here, summertime, big cloud. What kind of cloud is that? Anybody remember from like grade 2 science? Cumulonimbus. It's a cumulonimbus cloud. This is a thunderhead. Okay, these are the ones that build up on a hot, muggy day in like June and July. All right, so in June and July, okay, we get these things building. How do they build? What kind of conditions are necessary for a thunderstorm to happen? It's got to be hot, humid, and calm. Okay? Thunderstorms typically don't build well if it's really windy, right? Because it disrupts the circulation that is required to build a big tall cloud. Right? So typically you're not going to get a thunderstorm on a day that's really windy, okay? Because usually that means pressure is changing, whereas on a day when it's calm, okay, pressure is fairly stable, and these clouds can just build and build and build. So here's what happens. During the day, so in this diagram here, okay, the sun is heating the earth, and it's evaporating water off the earth's surface and from plants and things like that. So that hot, humid, wet air begins to rise. Okay? And as it rises, it gets cooler. What happens to air when it gets cooler? Or water, sorry, when it gets cooler? It condenses back into liquid water. Okay? So we see that we've got water vapor and we've got tiny little microscopic water droplets, and that's essentially what clouds are. Okay? It's little tiny water droplets that are small enough that the updraft from all of this heavy wet air can keep them aloft. Okay? They can't fall back down. Water droplets have to get to a certain size before they can actually fall back to the ground. So they continue to remain aloft. That's the cloud. Okay? As this process continues, the cloud gets taller and taller. Okay? And you start getting cycles through here. Okay? So those little tiny water droplets that are making the cloud, they don't stay in one place. They try to fall back down. Okay? And as they fall back down, they typically merge with other small water droplets, making the water droplets get bigger and bigger. Okay? But as the day goes on, you get so much evaporation that there is such an updraft that now fairly large water droplets can remain aloft. Okay? So they'll go through this cycle, building the cloud taller and taller and taller. Okay? Now eventually what starts to happen is you get really big drops of water that are trying to fall down, but the force of that warm air pushes them back up. If they keep going up, they'll eventually reach a point where the atmosphere's temperature is below freezing. They'll get pushed high enough that they will and become hail. That's how hail gets formed. Here's the worst part. Those hailstones will do exactly the same thing the water droplets did. They'll try and fall, but all this warm, wet air creates such a force upwards that they'll get pushed back up. Now, In the air that's pushing them back up is moisture. And they're very cold as a hailstone. So what does the moisture do? It condenses onto the hailstone and freezes onto it. You ever look at a broken hailstone? You can see the layers inside. Next year when it hails, check it out. You'll go outside and grab one. Okay, break it open, and you can see that it looks like a target almost when you look at it from the side. Okay, inside of a hailstone, there'll be kind of a core, and then there'll be definite other circles, okay, inside that hailstone, where that hailstone has gone through the cloud a bunch of times. They're almost like a tree ring. You can tell how many times the hailstone was pushed through that cycle based on how big it is, right? If we're getting, the little pea-sized hail, it didn't get a chance to go through the cycle very many times. Okay, you start getting, a little bit bigger, it went through a few times. You get golf ball size, those probably went through a half dozen times or so. Okay, they're getting pretty big. You get the baseball, that's gone through a lot of times, okay? And usually baseball-sized hail, those come along with like tornadoes and stuff, okay? You don't usually get those from just a regular thunderstorm, all right? And in extreme cases, grapefruit-sized hail, softball-sized hail, ice cream pail-sized hail. The largest hailstone ever, when melted, contained 3.86 liters of water. That is 1 gallon. Okay, that is an ice cream pail. Okay, went through somebody's roof. You wouldn't want to have been outside when those were falling down. Okay, yeah, that would have been real bad. Okay, I know in Wayne right now, about 11 or 12 years ago, they had softball-sized hail. Lots of it happened one day. And like all the houses, windows were busted out of all the houses. Every house needed to be reshingled in the town, and all the car dealers' inventories written off. Brand new cars and trucks. Don't have any miles on them. Never been driven anywhere. Written off. Okay? When a bunch of softballs land on a car, and they're not soft, right? Softball size, it's so hard as a rock. Okay? It's essentially like throwing a whole bunch of rocks at brand new cars and trucks. Okay? Not that anyone would do that, but nature did. Mother Nature was really angry that day. Okay, and yeah, I mean, all the windows busted out, all the bodywork completely totaled. Okay, like just dents everywhere. Right? What do? You sell them for parts, not any of the body either, because that was all no good anymore. Okay, so yeah, pretty major insurance claims going on there that day. Right? Okay, so that's how thunderstorms happen. Now, if you get a really big thunderhead, yeah, you're going to get hail, but sometimes you also get a tornado, okay? And that's because you start to get a real difference in pressure between the bottom of the cloud and the top of the cloud, because all the air has been moving upwards, okay? So you get kind of more dense air above and less dense air below. You get low pressure down below, you get high pressure up above, and nature doesn't like imbalance. And when it reaches a certain point, it funnels. Right? And there's such a massive change in pressure that a vortex forms to equalize the pressure. That's a tornado. Okay? It drops out of the cloud, spins and blows like crazy until the pressure is balanced again. Okay? That's what causes a tornado. Anyone been around a funnel cloud or a tornado? Yeah? It is scary as hell. Holy smoke. You've never seen, like, you understand how powerful nature is in basically like 3 times in your life. If you see a volcanic eruption, you've been in a tornado, you've been in an earthquake, okay? Or a flood. Let's include flood because we saw that. Okay, floods are really, that's humbling when you see what water can do. But yeah, like it's just, you are so helpless. You just realize how powerless you are in those kind of situations. Okay, I've been around several tornadoes, and it is so scary. I don't know why people chase those things. I think those people are absolutely nuts.
Last year was a lightning storm, like a major one.
Yeah.
And as soon as we got to our grandparents' house, we ran into their house, and like not even a few minutes later, lightning struck right next to their house, like
Yeah.
on the big power pole.
On the big power pole.
And everything just like we were actually like, there's just lightning going down.
Yeah. Now, my house got struck 2 years ago. Fried all my television sets, like 4 TVs fried, all the cable boxes fried, the Wii was fried. Okay. And I had surge protectors. I had surge protectors on everything. But the way the cable guy did it, he hooked it up and he ran the cable. And I had a surge protector the cable was supposed to run through. And he didn't run it through. So the surge went through the cable. Anything connected to any device connected to the cable, fried. So all my surge protectors were essentially useless. Yes. Yeah. Yeah. Try and put it out right away. Yeah. Lightning is scary close up. Anyone been close to lightning when it strikes? Okay. I worked at a golf course for a long time. When you work outside during the summer, you get really close exposure to tornadoes and funnel clouds and lightning. I was on a big machine cutting grass at the golf course, and big piece of metal. And you got your hearing protection on, so you don't really hear anything. And I didn't notice any of the lightning because I was looking down where I was cutting, because you got to make sure your lines are straight, and didn't hear any of the thunder. And then all of a sudden, as I'm turning, I see this lightning strike a tree, and the tree doesn't just start on fire; it explodes. It's like someone put a grenade in the middle of the tree, and it went off because the sap boils instantly. And so it expands inside the tree, and the tree can't contain the pressure, and the tree just blows apart. Okay? There's pieces of wood everywhere, just like splinters all over the place. The tree just explodes. And I'm sitting there on this big hunk of metal going, I'm going to die. Because I'm out here and I'm a human lightning rod. Okay? So I promptly jumped off the machine and hid in the sand trap until someone came to get me. It was cowardly, I admit it, but I didn't get struck by lightning. So you got to be mindful of things like that. Okay, lightning is very, very powerful, and you don't want to get hit by it. Okay, and the weirdest thing is, anytime you're near lightning, it's gonna strike. Look down at your arm, and all the hair is standing on end. Okay, we had it at a track meet one time that I was at, and I'm looking at the kids, and I'm like, everybody get down, everyone lay on the ground right now, because everybody's hair was on end. Everyone, our hairs on your arm, everything was just on end. Everybody. And we're like, oh my God, we're standing right next to the football standards. Right? It's like, yeah. Okay. You always got to be mindful. Okay. Mother Nature is very powerful, and it's all because of the interaction between these kinds of things. Okay. Factors that affect climate. The number one most important factor affecting climate is where you are on Earth, latitude-wise. How far from the equator are you? Okay? So if ever on a test I gave you a location and said, describe the most important factors affecting climate for this location. So let's say I picked, I don't know, Rio de Janeiro. Okay? It's in Brazil. You could write latitude for that. If I gave you Moscow, Russia, you could put latitude for that. You could put latitude for any place on Earth, because latitude affects the climate of every place on Earth, because it affects how much sun you get. And it affects the quality of the sun you get, the intensity of it. All right, so looking at this diagram here, if I'm at the equator, the sun is directly overhead. So I get very intense sunlight. Okay? All places on Earth essentially receive, let's say that line represents a unit of sunlight, okay? If it's directly overhead, it's very intense. But as I move this way, and I get further from the equator, whoop, I'll go the other way. I don't want that one. Okay, you can see here that now, that line used to take up the whole band, but now, because the Earth is round, that same amount of sunlight is being spread over a larger area. See how my line doesn't reach either end anymore? Okay? And it gets worse the further away you get. Okay? Up where we are, that same amount of sunshine is spread over an even wider area. So it's not as intense, so it's not as warm. Okay? Now, this is the Earth's orientation 2 days of the year, straight up and down. Okay? Which 2 days of the year is it straight up and down? Spring and summer equinox. Okay? So March 21st. and September 21st. Okay, those are our days of equal night and day everywhere on Earth. Everywhere on Earth, that day, 12 and 12. Okay, that's only 2 days a year. Now, in the wintertime, though, for us, the Earth is tilted. Okay, in fact, the Earth is tilted kind of all the time, but it wobbles back and forth. Okay, so the Earth's tilted 23.5 degrees. So in the wintertime, we're tilted like this. Okay, so now, are we even in a worse situation than this top band? Yeah, and here's the even bigger deal. This dotted black line is what we call the terminator. Okay, it's the end of day and the beginning of night. Okay, it's kind of the defining line. If the Earth is spinning around on its axis, this red line, okay, it's over here, right? How much into the sun do we get? Actually, you know what? I'm going to diagram this a little better. This is kind of looking weird here. I don't like how this is looking. Okay, here's the Earth. Okay, here's the Earth's axis of rotation. Okay, the line between day and night is right here. So when the Earth spins, okay, it spins around this axis here. Everyone follow? All right, so in the wintertime, our days are really short because we only get into the sun for that small amount of time. Okay? It's why in the wintertime the sun is also lower on the horizon. I don't know if you've ever noticed that, but the sun kind of rises over there in the southeast and it doesn't get very high above us before it sets over in the southwest. Okay? In the summertime, we're in the opposite situation. Okay? The Earth is now tilted this way. So when it rotates around the axis, the sun being kind of over here. That's terrible. But, okay, that's the sun. Right? Now, and we're not that close to the sun either. Okay? But now when we rotate like this, we stay in the sun a lot longer. We got all this time, okay, that we're in the sun, plus all that stuff on the backside. Okay? Where we're in the sun. So days are like 16 hours long, 18 hours long, okay, in the summertime because we stay in the sun. And it's more directly overhead. It's more like being near the equator. Okay? So we get higher intensity sun, and we get it more hours a day in the summer than we do in the winter. Okay? If you're at the equator, does this change very much? It doesn't. Okay? The Earth's tilt hardly matters at all at the Earth's equator. I remember my sister got married in Hawaii. We went there, and it was in August. And the lady who was at the front desk was complaining that the days were getting shorter. And I kind of scratched my head. I'm like, are you serious? She's like, yeah. You know, like by December, there'll only be 11 hours of sunshine. And I just went, you know, you need to come up to Canada in December. She said, why? Because then you'll know what a short day really feels like. Okay? When the sun comes up and you see it for like 4.5 hours before it goes away. That's a short day. Don't complain about 11 hours sun. Okay? Yeah, I did. It's like, that is ridiculous. That is the most ridiculous thing I've ever seen. Okay. Yeah. So at the equator, it doesn't really make much difference. That's why, guys, in Canada, we have daylight savings time. Okay? But if you go down into the southern states, they don't have it. Okay? Lots of the southern states don't have daylight savings time because their days don't change in length enough to be bothered doing it. All right? We have daylight savings time because the days get so short that we want to move the hours back in the fall so that it's kind of like the sun comes up earlier. It doesn't really, but we change the time so it makes it seem like it does. Okay? That way, it's actually safer for people when they're driving to work or kids are getting on the bus in the morning, okay, things like that. They're not doing it in the pitch black, at least not for 6 months. Okay? You want to follow there? All right, so that's all latitude. Latitude has a huge effect on your climate. The closer you are to the equator, the less the tilt of the Earth affects you. The further you are from the equator, the much bigger role it has to play. All right, next factor that affects climate, and you could list this for pretty much everywhere on Earth too, is altitude. The higher up you go, the colder it gets. Okay? The atmosphere gets thinner, its ability to retain heat is diminished, okay? So it gets colder. That's why the tops of mountains are often covered with snow well into summertime. Okay? Some mountains, they always have snow on the top. They got a glacier on the top because the higher up you go, the colder it gets. Okay? By about 6.5 degrees, for every 1,000 meters in elevation you gain. Okay? What's our elevation here in Okotoks? 1,094 meters. Okay? Here at the school, it's 1,094 meters. I'll just double check. Pretty sure that's what it is. 1,095. Probably depends where you are on the school grounds. Okay, so 1,095 meters. We are 1 kilometer and a bit above sea level. Okay, so much higher than like Vancouver or Victoria would be. Okay. Everybody follow me there? Okay, so that's pretty high altitude. So on average, we would be 6.5 degrees cooler on average. There's other factors, obviously, okay, than a place that would be lower than us. Now, you really see this if you do a lot of backpacking. If you ever go into the mountains and you have really big elevation changes, you can really see the effect of this even in one day if you do a lot of ascents. I used to do a lot of climbing and backpacking. I took this picture on a hike I was on with my dad. We left our campground, which was at 1,400 meters. So it's like down there somewhere, not in the picture. Okay, and we climbed up. This is Mount Robson here that you can kind of see in the background. It's the highest peak in the Canadian Rockies. Okay, we climbed up to here, which is called Snowbird Pass, and it was 2,200 or 2,300 meters in altitude. So we come up almost 1,000 meters from our campsite to here. When we left our campsite, it was 16 degrees and cloudy. When we got to here, okay, it was like 6 degrees, and it was snowing a little bit. Okay, on the top of Mount Robson, there was a blizzard. Okay, and several climbers who were stupid and tried to climb in a blizzard got blown off the mountain that day. Okay, you don't try and climb in a blizzard, because up there at the top of Mount Robson, which was still another like probably 2,500 meters above us, okay, it was well below zero. The winds were blowing really hard, and the little bit of kind of snowy, wet snow / rain that we were getting was a blinding blizzard for them. Okay, yeah, most climbers die because they make the wrong decision. Okay, when weather gets bad, which direction do you go? Yep. Okay, unless it isn't safe to go down either, then you try and stay it out. Okay, yeah, but I mean, it's tough. Like people on Everest, they get killed all the time because I got to get to the top. I did all this work. I got to get to the top. Well, you get to stay there now. Yeah. Okay? Because you guys know that, right? They don't bring you down. Eh? You die on the mountain. You stay on the mountain, right? It would be incredibly difficult to carry someone in that thin of air. So that's the rule. Okay? It's weird. If you've ever seen any documentaries and stuff of Everest and K2. Once in a while, they'll be climbing the mountain and they'll pass a body in the snow. It's disconcerting, to say the least. Okay, so that's the effect of altitude, plays a big factor. Okay, the higher up you go, the colder it's going to get. Okay, distribution of land and sea. The ocean plays a huge part in climate. Okay, this year we're in an El Nino year. That's an ocean current. We're going to talk about that later. Okay, but the ocean can hold a lot of energy. And in most places, the ocean doesn't freeze. Okay, at least even like in Canada. Once in a while, around Labrador and Newfoundland, places like that, it'll freeze a bit. Okay, but most of the time, the ocean stays in liquid form. Okay, so it can really retain a lot of heat. And the second law of thermodynamics says that heat has to flow from hot to cold. So if you've got an ocean that's even, let's say, 5 degrees Celsius, 6 degrees Celsius, kind of like it is on the west coast here. It's very cold. If you've ever been to the ocean on the west coast, okay, it's quite cold. You look at this ocean, you're like, yeah, you're going to go in there, and it's freezing when you get in. Okay, that's why you can always tell the Canadians in Hawaii. We approach the water differently than other people. Okay, you can tell the Canadians because we come up to the water and like, oh, this water's very warm. That's so weird. Okay, people from the States are like, ah, they just run in and they get all, because they know they figure the ocean's going to be warm. So it's really funny if you watch them go into our ocean. Okay, so Land gains and loses heat faster than water, so temperature ranges are greater inland where the ocean cannot reduce the energy gains and losses. So in a place like Vancouver, where the ocean is not going to freeze, the air temperature also rarely gets below freezing, because if the air temperature tries to drop below the temperature of the ocean, energy flows out of the ocean and into the air and warms it back up again. Okay? Which is why climate in like Victoria and Vancouver is very temperate compared to here. Their latitude isn't a lot different. Their altitude's different, for sure. They're 1,000 meters lower than us. Okay? But their latitude, they're pretty much the same distance from the equator that we are. But the ocean really regulates their climate. Right? It rarely snows, okay, in Victoria or Vancouver. It'll snow in the mountains further up, okay, but it rarely snows in those places. When it does, the whole town shuts down. Okay? They don't have like a lot of snow removal equipment in a place like that. Okay? All right, does that sort of make sense? Okay, now, related to the how close to the ocean you are is, distribution of land and sea. So we're very far inland, okay? Can the ocean affect our climate out here? Excuse me, can it affect our climate out here? Not really, okay? We're too far away. And like we said, inland places tend to have much greater fluctuations between winter and summer, okay? Because the ocean doesn't have that ability to regulate. Now, nature of ocean currents, okay? We can see here that we've got the subarctic current, the Alaskan current here, the California current. We've got currents that are coming in from other parts of the ocean, right? On the west coast, even though we've got these drawn as kind of cold water currents, they're coming from over here, okay, which is, you know, a little bit north, but they actually come more like this, kind of from the Hawaii type area. As they come up, they get cooler, but this part of the ocean rarely freezes right here. Whereas on the east coast, the ocean current that's happening is coming from the Arctic Ocean. Okay, so we've got really cold Arctic Ocean water coming down, and we got the Labrador current, okay, and that kind of stuff going around Labrador and Newfoundland, which is why the ocean is very cold there and does often freeze in this area. Okay, Newfoundland has very harsh winters. Pacific side of Canada, same latitude, very mild winters. Okay? Has to do with where did the water that's here come from? Did it come from a warm area? Yes. Did it come from a cold area? Well, then we're going to have a difference in that kind of thing. Right? Everybody follow me there? Okay? You look at, you know, the northern United States, they've got, you know, the North Atlantic currents, okay, and the Gulf Stream and things like that that are warm water currents. They have typically more mild climates. Okay. Now, El Nino is also an ocean current, okay, and we're having that this year. It's an upwelling of warm water that occurs about every 6 to 8 years, just off the coast of Argentina. Where's Argentina? Next to Chile, South America, okay, way down below the equator. That upwelling of warm water can raise ocean temperatures by a couple of degrees. How come it's so mild here then? We're not close to the ocean. If the global ocean temperature changes by a couple of degrees, why does that affect us so much? Yeah, the ocean makes up most of the planet. Okay, it's like between 2/3 and 3/4. Okay, it's a huge part of the planet. It's a lot of water. Think about how much energy it takes to boil a pot of water. Okay. It takes a fair amount of energy to boil a pot of water. Well, now, look at all the water on Earth and imagine trying to raise its temperature by 2 degrees. Does it take a lot of energy? A lot, okay? So there's a huge amount of energy that's coming from this upwelling, okay? And it can affect global temperatures, okay? Everywhere. Everywhere feels the effect of El Nino. Okay. Distribution of mountain barriers. If we were going to list factors that affect the climate of Okotoks, we would have latitude, we'd have altitude, and we would have this one. Okay? This is huge. The mountains are a huge part of our climate because we get Chinooks off of them. See, again, Leo should be listening to this. Okay. All right. So here's how that kind of works. Okay? On the BC side of the mountains, okay, which we call the windward side, okay, this wind is coming off the ocean. So it's warm and it's moist. Okay? So it's coming off the ocean, and as it hits the mountains, it has to move up to get over them. Well, as it goes up, it cools off. And what does moisture do when it cools? It condenses and it falls as rain. If you've ever gone into BC, the forests in BC look a lot different than they do in Alberta. Okay? They're temperate forests. Okay? Ours are more like taiga type forests, are drier forests. Okay? So you got temperate rainforests over on this side because that's where all the rain falls. The mountains cause that air to cool, and most of the moisture falls on the BC side of the mountains. Okay? By the time that air is finally forced up and over the mountain, it's dry and cool. But as it comes down the mountains, it builds up speed. Okay? There's drag there. There's all kinds of stuff that builds up not only kinetic energy, but also thermal energy. Okay? There's a lot of thermal energy that builds up as this air now descends down off the mountains. So as it comes down, it warms up, speeds up, and blows across the prairies. Now, it's dry, so it actually often sucks the moisture out of this area. That's why you see prairies and desert on one side of the mountains and temperate rainforest on the other. Okay? If you've ever been to Hawaii, this is a place where you can really see it. Okay? You can see the windward side, it's covered in jungle, and then the leeward side is desert. Okay? Like places like Maui and stuff like that, they're in like the desert part. Okay? Whereas on the Big Island, if you're in like Honolulu, you're typically in the more rainforest-like part. Okay? There's a very definite difference between the two sides of any mountain range. Okay, so that's probably, other than latitude and altitude, this is the next biggest one affecting our climate. It makes the Chinook. Okay, it makes it dry here. Okay, makes it reasonably temperate in terms of temperature. Right, you go further north, like you go to Edmonton, do they get Chinooks? No, because they're too far from the mountains. And it gets to be too far north. They start to get into where the prevailing winds begin to change. Which leads us nicely to prevailing winds. Okay, we're actually going to have a whole lesson on how winds work. Okay, but we're kind of right at the northern edge of the westerly prevailing winds. You get up to Edmonton, and they actually start getting more into the polar easterly section of the prevailing winds. Okay, so where your winds come from on a regular basis affects your climate, because they typically bring the same kind of air. Which is what we were saying earlier. If the wind ever comes from the northeast here, we know we're in for something different. Okay? If it's coming from the southwest, we know we're in for dry and sunny and all that kind of stuff. Okay, and then 7, locations of centers of high and low pressure. Right, so there are some places on Earth that just typically have high atmospheric pressure and some that just typically have low atmospheric pressure. Right? One of the places that's typically high is right here. Okay? Right over the Northwest Territories there. It's called the Siberian High because it's pretty much always there, and Siberia is a very cold place, so this is called the Siberian High, right? And over here is always low. It's called the mother low because it always spawns these little low pressure areas that kind of come spinning off of it, and they create changes in weather for us. So if you look at where these two things are, okay, here's something we got to realize. Rotation around a high pressure area is, I always get this wrong, it's counterclockwise. Around a low, it's clockwise. Okay, so air circulates this way around a low and it circulates this way around a high. Now, what that means is cold, dry air often interacts with warm, moist air. And when they throw off small, like little weather kind of bodies or fronts and things like that, okay, they meet each other right here and go right down through there. That's the Tornado Alley of Alberta. I mean, that line pretty much is Highway 2, right? Okay, that's why we get rapid weather changes. Those two high and low pressure areas often interact. And when they interact in the wintertime, that's when we get huge blizzards and snowstorms and whatever else. And in the summertime, it's when we get huge thunderstorms, okay? Like that last several days where we just get rain and rain and rain. Those two things interacting, cold air with warm, moist air, is always a combination for, okay, a violent change in weather. Okay, is that making sense? All right, so where we're kind of headed with this, guys, is when we come back from Christmas, we're going to do an activity where we're looking at Canadian cities, we're looking at their climates, and we're going to try and figure out which factors are most important and which ones kind of affect climate the most. Okay? That'll be climatograms, which I'll talk about a little bit tomorrow. Okay, tomorrow we'll probably talk more about heat transfer, and then when we come back, we'll do climatograms.